This is Ms. Wiles, and in this video we'll start off by classifying sequences as either arithmetic, geometric, both, or neither. To effectively classify sequences as one or both of the types of sequences that we have, or possibly even neither, we need to be able to check the sequence for the common difference, if it's going to be arithmetic, or a common ratio, if it's going to be geometric. Sometimes you have to check for both, and sometimes checking is it feels like just looking. Like you're just looking at the numbers and you're like, oh, these numbers are too big, they're getting too big too fast to be arithmetic, so they must be geometric, or possibly you might actually just have to check. You might have to check everything to see what's going on. So what we do is we take a particular sequence or a list of numbers, because we don't even know if it's sequences yet until we actually check for a common difference or a common ratio. So let's take this one. We'll bring it over here into the spotlight. So if we want to see if it's arithmetic, we should be looking for a common difference. And to find a common difference, we would take these numbers and we'd take the second number and subtract the first. We will get an answer for that, which looks like it will be 9, negative 9. So we check the next set of numbers that we have. The next set of numbers is 64 minus 73. We check that difference, and that difference is also negative 9. And then we take the third set of numbers that we have here, the 55 minus the 64, and that's also going to be negative 9. If every one of those is exactly the same, meaning common, that's common. When something is shared, it is common. When it's all the same, it is common. If all of the differences are common, they are the same, that means that that particular list of numbers is an arithmetic sequence. Now, because there is an option for it to be both, we need to check at least by sight and say, could it be that we're multiplying by something too? And I'll tell you the truth, most of the time it's not. If it's arithmetic, it's not going to be geometric most of the time. I'll show you an example of when it would be, but in this case it wouldn't. If we were checking for geometric, we would do 73 divided by 82. We'd do 64 divided by 73, and 55 divided by 64, and those are not the same at all, so it can't be, these are not common. They don't have the same ratio whenever you compare them geometrically. So the only category that this particular sequence or list of numbers fits in is arithmetic. Okay, so I'm going to erase this stuff so we have more room to work. And we might not write everything down, but this particular list goes in the arithmetic sequence column. Now we look at this sequence. I'm calling it a sequence just because I know that it already is. If it didn't fit into one of these categories, then it wouldn't be a sequence, it'd just be a list of numbers, because you could just have a list of numbers. When we look at this, going from negative 6 to negative 30, we're either thinking or writing or making a note that we would have to multiply by 5 to get to negative 30. So then we think, okay, would I be multiplying by 5 to get to negative 150 from negative 30? And the answer is yes. And then am I multiplying by 5 to get to negative 750 from that negative 150? And the answer is yes. So when you see that you're multiplying by 5 each time, that's your common ratio. And this sequence, this list of numbers, fits in the geometric sequence column. If we didn't have a real good number sense and we couldn't really figure out what was going on arithmetically, we can actually look and see from going from negative 6 to negative 30 would be negative 24. It'd be going down 24. And going from negative 30 to negative 150 is going down 120. And that's a huge difference. It's not the same at all. So arithmetic doesn't fit at all, and the only column that this particular list of numbers fits in is geometric. And so outside of the video, I erased all that and we put it in geometric. So we're back in, now we're looking at this 100, 100, 100, 100. Well, let's look at it geometrically. Geometrically, to get from 100 to 100, we'd be multiplying by 1. And to get to 100 to 100, we're multiplying by 1 again. And we're multiplying by 1 again. So it's geometric. Is there a number that we could add to 100? And it's 0. So we have plus 0, plus 0, plus 0. It is when you have a list of numbers like this that it will fit in both categories. So when both of those are the same, this sequence will go into the both column. So to summarize all that, when you're doing an arithmetic sequence, you're either adding or subtracting the same number every time, which is called a common difference. In geometric, you are multiplying. You are multiplying by the same number. It's called a common ratio. And of course, both is both. You have arithmetic and you have geometric. With neither, you may have a nice little pattern, but you don't have either the common ratio or the geometric. You might have a pattern though. If you're looking at this particular set of numbers, it's a nice little pattern. It's actually a pattern of perfect squares. Because when you look at this, 10 squared or 100, you should know that number by now, that it's 10 squared, that it's a perfect square. And 121 is 11 squared. And 144 is 12 squared. And 169 is 13 squared. And this is how they get you on a test or something, because they give you a list of numbers that has a nice pattern, but it's not geometric, it's not arithmetic, so it doesn't fit in either one of those categories. If we were to look at what's happening here, we're adding 21. For the next two numbers, we're adding 23. For the next two numbers, we're adding 25. Now that's a nice little pattern, but it's not a common difference because we're not adding the same number every time. So arithmetic is out. And geometric, 121 over 100 does not equal 144 over 121, which does not equal 169 over 144. And when those things happen, then that list of numbers is neither a geometric nor an arithmetic sequence. So back into the video, if you were in class, we went through all of these and talked about which category each one of these lists of numbers would fit in. And if you're in my class, you can come in and ask any questions about these, and if not, ask somebody else. Let's go on to explicit formulas. An explicit formula is just in your face. Here it is. You can find anything you want from this formula. It's based on n. N is a variable that is used so often in sequences. It represents a particular space in the list. N is, it's hard to explain. It is the number of the term, not the value of the term, but the number of the term. So if we have a list that has 5 numbers in it, 4, 5, that's 6. Apparently I can't count. In this list of numbers that has 6 numbers in it, this n is 1, and this n is 2, and this n is 3, and so on. Those are the values for n. It's not always 1. It's only 1 when you want the first term. Explicit is in your face. The only thing you need to know, if you know the explicit formula, is which term do I want. So it's based on, when you see a function that's based on that number, it's based on n, then that means you're looking at an explicit formula. And that explicit formula is going to have a number out here. And that number is going to be the first number in the sequence, the 4. The 4 is the first number in the sequence. And then inside of that, you have that common difference that we've talked about. and then n minus 1. Now the reason it has to be n minus 1 is because whatever that common difference is, I'm not going to add it until I get to the next number. So if my function ends up looking like 3n plus 4, then
you do 3 times 4.
Well, it wouldn't look like that if I wrote it all the way out. It would end up looking like 3 times n minus 1 plus 4. The 4 is the first number. If I substitute 2 into that particular formula, if I see 3 times 2 minus 1 plus 4, then I'm going to add 4 every time and I just get 7. Now, what I want you to get out of this is that if you have to find the terms in the explicit formula, you can just plug in n equals 1 for the first one. And you can just plug in n equals 2 for the second. And n equals 3 for the third. So there's nothing hidden about it. I don't have to know what the second term is to find the third one. I just need to know what the equation is. If we take all this away, and if the equation is 3 times n plus 1, because there's some magic that happens. Would you like to see the magic? Let me show you the magic that happens when you have what we had before. Here was the 4 that was the first number. Here was the 3 that was the common difference, because I'm going 4, 7, 10, 13, 16, 19. I'm adding 3 every time. What happens when I put that n minus 1 here, and then I'm adding the 4 because the 4 is the first number, what happens when I'm finding the final equation for this is that I have to use the distributive property on the 3 times the n minus 1. The distributive property there looks like 3n minus 3, and then there's a plus 4. Well, the minus 3 and the plus 4 are like terms. They go together, and I end up with 3n plus 1. And so then I can just go through and I can plug in n equals 1 for the first term. 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7. If I want the 22nd term in this sequence, I want the 22nd term, then I would go 3 times 22 plus 1, and that's going to give me 67. Because all I have to do is substitute the number of the term I want. Explicit formulas are a lot more straightforward and in your face than recursive formulas. Because with recursive formulas, you have to know the number that comes before it. And with explicit formulas, you do not have to. So in our handy dandy calculators, if we want to do this with a calculator, the first thing we have to do is tell the calculator that, hey, I'm working in sequence mode. I'm looking for a sequence here. I'm going to work in sequence mode. So there is a button on your calculator that says mode, and you're going to arrow down to this place where it's usually that we're working with functions, and we're going to change that to sequence. From there, look at the stat button, but above that stat button it says list. So now you'll choose second list. And the way that I remember that is that we're working with lists of numbers. We're working with lists of numbers. We want to find a list of numbers. Choose the second option, which is ops, and then choose number 5, which again is that SEQ standing for sequence. From there, the third step, when you press enter, you will see this on your screen. When you see this on your screen, once you are on this screen, and what you can see that between the difference in screen 3 and screen 4 is screen 4 was the old way that you had to do it. You had to know exactly what to put in with commas in between to give the calculator the command to do stuff. So they made it look in screen 3, if you can get to this screen, they made it look better for you to be able to put the equation, the expression, into the first line. And in this case, our expression is 3n minus 2. Now you might say, well, where do I get the n? Don't use the alpha n, but there's a button up there that has the x on it that you usually use for x. If you're in sequential mode, your calculator now knows that when you press that, it's going to give you n. And if you were in that parametric mode, it would give you something else. And if you were in one of these other modes in screen number 1, it would give you something else. It has 4 choices there based on which mode you're in, and it knows what to put. So you'd put 3n minus 2. In the next line, you'd put the variable being n. You would go straight to that same button and just press that button to put the variable in. Then you put what numbers you want. In this case, I want the first number, and I want to stop on the 5th number in the sequence. After each line, I press enter. After this 5, I press enter, enter, enter. And this paste, it's going to paste it on my screen, and it will look like screen number 4. It'll look like screen number 4, except for it'll only look like the first line. And I press enter, and I get the first 5 numbers in that sequence. This set of procedures in the calculator work for all explicit formulas. They work for arithmetic formulas. They work for geometric formulas. And we can do that on the next screen. We have 6 explicit formulas here that we are going to find the first 4 or the first 3, and we're going to do them here in class, one after the other. We're going to pause here to do negative 5n minus 10, find the first 4. Now you get to make a choice. Do you want to find them by using the 4-step procedure of putting this in the calculator and getting the entire list, or do you want to find them by doing 4 lines in your calculator, substituting 1 for n for the first number, substituting 2 for n for the second number, and so on until you get all the numbers that you want? We'll pause here and come back in when we have those numbers for the first set. Okay, the first one we have negative 15, negative 20, negative 25, and negative 30. This is what you should have seen in your calculator after you put everything into the calculator. If you notice, the first, or the difference, the common difference between each of these numbers is negative 5. Look at where, I want you to see that difference so that when you see explicit formulas, you can tell what's happening. And so we have negative 10 minus negative 5, and that gives us the negative 15. We do have to start there, but we can definitely tell the common difference just by looking at the expression. So now do the next one to the right. The 4 times 2 to the n power. For this one, this is what you should have in your calculator. If you're wondering how you would get this exponent when you're on the other screen, do 4 parentheses 2, use the caret symbol, and then the letter n for the exponent. Now go on to the third. In fact, we'll do the next 4 before we come back into the video. Okay. What you see in the blocks are the answers that would go there. I'm going to remove the rectangles here that are covering what you would have in your calculator. Of course, remember that you could do these by just substituting a particular number for n, especially if you only wanted, maybe you didn't want a whole list of numbers, maybe you only wanted the 7th number in the sequence.
We do a BB.
If you only want, for example, the 7th number in the sequence, then maybe it would take less time just to go to your main screen and substitute 7 for n. That's all I have to say about our second installment on the video series for sequences. That's all I have to say about that.